Hi, I'm Corbin Coyes, the Vice President of Engineering for Q2ALS for North America.
I'm Colin Heidel. I'm VP of Sales and Marketing for Q2 here in Canada.
So just to talk about this one device, it's a sand twister. It's probably the 17th revision we've got in the field, and just wondering if you've had some success in the field here. Can you kind of explain where and why, Colin?
Yes, we can. So we have a company in northwest Alberta that has a field of 37 wells where they had to shut in due to the fires last year. They had 7 of these sand twisters applied in their wells, and when they started the field back up, the only pumps to take back off were the ones with the sand twisters. And the reason for that is because of this design, it disallows the sand to get alongside the plunger. On the other designs, the sand fell alongside the plungers, and when they went to start them up, the plunger would stroke into the sand, and that sand would cause that plunger to seize. Therefore, they weren't able to pump. With this design, we were able to, with our bushing at a -2 fit, we were able to keep the sand from falling alongside the plunger. But with our bushing, we have a beveled edge, and in that edge would force the sand down through the ports back into the ID, the plunger, and carry it that way.
Nice. And I guess one other question I had for you too is there's been some modifications to this design. One of them was the colletted type sand twister. So when would you use that, and how's that been effective?
It's been very effective, and where we would use that is in deviated wells. We have a company just west of Red Deer here that this is a standard on each and every one of their designs. So we're able to run these down low round curves because of that extra strength. Now we're not seeing these any premature failures because of the metal that we've thickened on this particular design.
Nice. There's a few instances where that beveled edge has a radius that caught. I know we changed that design and we made it a little more beveled, and the -2 fit you said was probably a good thing too, as well as the design phase. And the angle we changed was a little bit too to strengthen it. But for the most part, I think in general, how many do you think we've run over the last 4 years just in Canada? I know it's in the US too, but what would be your ballpark number?
We're well in the hundreds of running these now. We have many companies that are running these. You know, the sweet spot's probably 15 to 2,000 meters where these really work well for us, but they're becoming more of a common component in sand applications, and we're seeing more and more companies utilize the technology.
Nice. I know a lot of cases operators are actually fracking their wells with fines instead of actually proppant like frac sand. So with the sand twister vortex here, do you think it's helping with the fines in the system?
Absolutely is. Because of the vortex in the cages and through the top of this neck, we're maximizing velocity with the fluid dynamics. We're keeping the sand entrained in the fluid, and we're moving it through at a faster rate, therefore it doesn't have an opportunity to settle back down again. So we're carrying it upwards in the tubing column once it's displaced.
Oh, that's interesting. Okay, so we've got the sand twister here. With the HVS valve, I know we've been running these for, I think, probably the last 4 years. So relatively new technology, although with the amount of shops we have thousands downhole running. Can you just tell me about whereabouts these have kind of started off and where they've grown?
The HVS valve has really taken off for us in southeast Saskatchewan, but we're seeing it all over Western Canada for sure, and I can be specific to that. We're west of Red Deer here again. We have a company that is exclusively running these now. We're into about 30 of these horizontal valves downhole, but they've found the sweet spot at 78 degrees. But we have several companies that are starting to use this. We have brand new companies that are utilizing this out the gate. And with everybody going into a horizontal dog leg, I think this will be the newest technology and the most certainly productive technology out there for the standard API rod pump.
So we listened to the field on this one because this is a universal pump. So they've had other inventions out there where they've tried to do stems and they've tried to pump horizontally with rod pump, but it wasn't strong enough and the flow wasn't quite there. So this will fit in every normal pump situation, like a traveling and standing valve, correct?
That's correct, yes. And I've had experience with some of these designs you're talking about in the past where they were a guided half-moon apparatus that we could lay flat, but they weren't strong enough on the shafts and they consistently broke. The technology just didn't hold up to the demand of the pump. This is where this is different with the strength of that valve, the barbell itself, the strength of the cage and the inserts within this, and the vortex. This is by far a superior design. And we're seeing that in the run lives we're getting, where we're 8 months prior, we're up to 30 months now in some of these wells where they couldn't keep them in the ground, and now doubling production and so forth.
Yeah, so with this technology, one of the challenges is getting production data from clients. And you hear so much word of mouth. I mean, when you're talking to the clients every day, is there a specific situation or one that you can't name the client, but you can name a field and where you saw an improvement? Okay.
Yes, definitely. And Drayton Valley is one of those areas where, you know, we've doubled their production. They're excited about this valve, but we're seeing these new companies coming and trying these, and we're getting the data and graphs pre and post horizontal valve, and you can see the production increase. You can see the consistency of the production. It's not so up and down anymore and all over the place. So that's another thing that this valve is doing for us. So overall, it's just a better design.
Well, it looks like we're tripling our production every 3 months. So across North America, I think this is one valve to look out for. It's the Horizontal Valve System for Q2ALS. And I believe that eventually it'll probably go in the verticals too, because around the verticals that have the double valves in the ground, it seems like this would be a good fit when it comes to the field application.
Yes, I believe it would be. I mean, there's a lot of issues with double valves that this will eliminate in gas and sand related issues, with those two valves being close and difficult to get sand through, their velocity, slow down, pressure drops, all that other stuff. This will eliminate that and allow us to pump them more efficiently.
Nice. All right, well, that wraps up the questions for today. Thanks, Colin, for all your experience in the field. I know you go to pump shops all the time and you get the word right from the horse's mouth, so I really appreciate that. And yeah, it's Corbin Coyes signing out.
Yes, and any information that you want on these horizontal valves, please contact our field representatives at any time, and we can look at designing wells for you to maximize your production. Thank you.